We're now going to continue our discussion of hypothesis testing. In the previous lecture presentations, we've discussed writing the hypotheses, which is step 1 in the hypothesis testing process. And we've also looked at finding the critical value, which is step 2 in the hypothesis testing process. We're now going to take a look at an example and work the problem from start to finish, doing steps 1 and 2, and then adding in the remaining 3 steps. The example that we'll use states, it has been reported that the average credit card debt for college seniors is $32.62. The Student Senate at a large university feels that the debt is much less than this, so it conducts a study of 50 randomly selected seniors and finds that the average debt is actually $29.95 and the population standard deviation is 1100. With alpha equaling 0.05, is the Student Senate correct? So let's begin with step 1 of the process, which, as we learned in the last lecture presentation, is to write the hypotheses. So what I want to do is I want to read back through the problem, and I want to look at specifically looking for something that's going to give me a key as to what one of the hypotheses might be. The thing that I note is the sentence that says the Student Senate feels that the debt is much less than this. And so that tells me that one of my hypotheses, and I'm not sure which one at this point, but one of my hypotheses is going to be that the average debt is less than, and then I need to ask myself less than what? It was reported that the average credit card debt for college seniors was $32.62. The Student Senate thought it was less than this. Okay, so that is one of my hypotheses. Now I need to ask myself which one it is. Remember that we said that the null hypothesis, that the definition of the null hypothesis was that there was no significant difference, or in other words, that it was equal, that when we did our own research with the sample, that our research equaled the accepted mean. And since this hypothesis doesn't have the equal to option in it, I know that it's not the null hypothesis. And so I'm going to go ahead and label this one as H1 and say that that's the alternate. We also said on the hypotheses that your hypotheses between the two statements, that they have to include every possibility. And so if the alternate hypothesis has a less than, then the null hypothesis, which I'm going to squeeze in right here, will have a greater than or equal to. And writing them that way means then that I've included every possibility. I have a less than in the H1 and I have a greater than or equal to in the H0. Now I also, as part of step 1, which we didn't do before because we weren't actually looking at a problem, is to identify one of your statements as the claim. So think about what it is that you're actually trying to show. You're trying to show that the Student Senate is correct. And so the Student Senate thinks that the average debt is less than, and so I'm going to put the word claim next to the H1, and that will be my claim. Okay, so let's move on to step 2. Remember that step 2 is to find the critical values. And so for this step, I need to draw a picture of my standard normal distribution curve. And I need to decide which side of the curve to shade. Remember from our lecture presentation on the critical values that we noted that you should always shade the part of the curve where the significant difference lies. And then we went on to say that the H1 hypothesis is the statement that shows the significant difference. That's the definition for the alternate, is that there is a significant difference. And so we concluded that we should shade based on what the H1 says. And since the H1 has a less than, I'm going to shade to the left and making it a left tail test. Now, one thing that tends to be a problem for students in this hypothesis testing chapter is when they're determining where to shade, oftentimes students will look at the claim and use the claim to determine where to shade. And that is an error. We will shade this on the left-hand side because the H1 hypothesis has a less than. Even if the claim, for some reason, was the null hypothesis, the picture would be exactly the same as what we have drawn here. So you want to be cautious that you don't look at the claim to determine how to shade, but that you look at the alternate hypothesis, the H1 hypothesis. Okay, we are told that alpha is 0.05. And so remember that alpha is the area of the shaded region. And in order to use table E, I'm going to need to determine this piece, the piece that lies between 0 and the z value. And so that piece, subtracting 0.05 from 0.5, gives me 0.4500. And looking that up in table E, I can determine that my critical value is going to be negative, because it's on the left, 1.65. Now, those two steps are simply a review of what we learned in the last lecture presentation. So if you're having trouble with either of those steps, you might go back and take another look at the presentation on either the critical values or on the hypotheses to be sure that you fully understand those two steps. Okay, let's move on to step 3. Okay, so what I want to do is I want to look at this 3262 for a second. And I want to ask myself, where does that occur on my curve? I know that that's the average credit card debt. And remember that when you're talking about the standard normal distribution curve, that the mean occurs where? Right, it occurs in the center. And so for right now, I'm just going to make myself a note that the 3262 occurs right in the center of the curve. Now the other mean, the sample mean, the 2995, I need to figure out where that one lies. So the idea behind what we're about to do is, remember that we want to show that the debt is significantly less than 3262. So remember that if my own research comes up with a value of, say, 3260, and that would mark off maybe right about there, would you say that that's significantly less? And no, I mean, while it's less, it's not significantly less. It's not enough for me to go to somebody and say, I think that your claim was wrong about the 3262 because I did my own research and came up with 3260. Okay, so that's not significantly less. And what about if I did my own research and I came up with, say, what if I came up with 3255, which is going to mark off, maybe right here. And again, not significantly less. It's less, but it's not significantly less. What if I did my own research and maybe I came up with that the average debt was, say 1,500, which is more than likely going to mark off way over here. Is that going to be significantly less? Yes. And so remember that the purpose of this shaded region is to define the area where we have significantly less. And so as long as when we're marking these things off, we don't get to the shaded region, then we're going to assume that it's not significantly less. But as soon as I cross the line and get into the shaded region, our values become significantly less than the 3262. Okay, so what I need to do is I need to figure out this 29.95, where is it on the curve? Is it somewhere over here where it's just basically less but not significantly less, or is it way over here where we would say it was significantly less? So basically I've got to figure out the 29.95, where is it in relation to this 1.65? And think about how you're going to do that, because the 1.65 is a z-score, and the 29.95 is just like this regular data value. And so in order to truly compare those two numbers, they've got to have the same units. And so step 3 is to take that 29.95 and convert it to a z-score so that you know where that number falls in relation to that 1.65, whether it's significantly less than 3262 or just a little bit less than 3262. Okay, so let's think about how we convert a number to a z-score. If you remember, in our last couple of chapters, we've done this. We've used this formula that looks like this. Now, back in chapter 6, we actually had 3 versions of this formula. Now we're gonna simplify that and say that it's always going to be this version of the formula. We're not going to let the correction factor come into play here because it just complicates things too much. And we're always going to be talking about a sample, so we're not going to have the version of the formula that doesn't have that square root of n. And so it's always going to be this formula. But one thing that we need to do is we need to be a little more specific with the formula now. We need to use the symbols instead of the words. We've gotten kind of in the habit of using value minus mean, when in actuality those have symbols for the value and symbols for the mean, and we need to go to those now. So that formula, that same formula with the symbols, looks like this. Okay, now let's just go through those symbols and be sure that we know what everything is. The X bar, remember, is the mean of the sample. This mu is the mean of the population. Okay, so that's your 29.95 and your 32.62. Those are your two averages. The sigma is the standard deviation of the population. And it's going to become important to us that we actually have the standard deviation of the population. If not, we're going to have to talk about how things might change in that scenario. And then the little n is the sample size. Okay, so let's go ahead and plug our values in. Remember that the value that we want to convert is always going to go first. That also holds with this X bar. This 29.95, they conduct a study of 50 randomly selected seniors. That's a sample. They find the average to be 29.95. So 29.95 is the average for the sample. The 32.62 is the expected mean. Okay, that's average credit card debt for all college seniors. They tell me the population standard deviation, so I'm good. I've got exactly what I want for the sigma. And my sample size is 50. Okay, when you put this in your calculator, you need to be sure that you are putting it in one step. You don't need to try to break it up and round here and round there and then calculate. Just put it in all at once. And the best way to do that is to stick a parenthesis around the top and a parenthesis around the bottom. Okay, and enter it in your calculator just like that. with a parenthesis around the top and a parenthesis around the bottom. And you should end up with negative 1.72. Okay, now please go ahead and try that on your calculator. You can pause the presentation and do that. Make sure that you can actually get that put in correctly to get the number, okay? And if for some reason you can't, then that's a good thing to email me and ask about. And let me make sure that you can get it in your calculator correctly. Okay, so now remember that $29.95 is the same as negative 1.72. This is a data value, this is a z-score, but they are equivalent. And our original issue here was knowing where $29.95 fell on my curve. Well, where does $29.95 fall? It falls at negative 1.72, which is just going to be just over the line here, but over the line. And that's the important part. Okay, so steps 4 and 5 are the steps where we actually just go in and make some concluding statements. All right, we've done all the calculations, we've done all the work, we just need to kind of sum it up now. All right, so step 4. For step 4, you are going to tell me what you plan to do with the null hypothesis. And step 4 is very specific in that you have to either say that you are going to reject the null, or you can tell me that you are not going to reject the null. Because of the way that this process is set up, you don't have a lot of flexibility here. You can't come in and tell me that you're going to accept the alternate or accept the null. Okay, your wording needs to be very specific here. You either need to say reject the null or don't reject the null. Okay, so let's think about which one's going to be the answer here. Okay, what does the null hypothesis say? It says that it's greater than, but more specifically, it says that they're equal. Okay? So the null hypothesis says they're equal. All right, let's keep that in our mind. The null hypothesis says they're equal. I'm just going to jot it up here so we don't forget. The null hypothesis says they are equal. All right, now, what do we think? Remember that if the $29.95 had marked off here, we would have said, yeah, it's less, but it's not significantly less, and we basically would have been saying it was the same. As soon as we cross over this line, we get far enough away from the middle line that we are significantly less. So the null says they're equal, and we're saying that no, $29.95 is significantly less than $32.62. And so we are going to reject the null. Okay, the null says they're equal. We're saying they're significantly less, so we don't agree with the null hypothesis, and we're going to reject it. All right, now step 5 is the step where you go in and you actually say, okay, how does this relate to the student senate's thought about the credit card debt? And there's a chart in your book in section 8.2 that's going to help you determine how to state your concluding statement. All right, so if you will take a second and get your textbook and flip through section 8.2, there's a chart. It's green and blue, I believe, and it'll go through and tell you. And it's actually, when you find the right page, it's on the page twice. All right, and it's actually going to go through and tell you how to state your concluding statement. Okay, so on that chart, if you're looking at it, and hopefully you are, the first thing that you look at is whether the claim is the null or the claim is the alternate. If the claim is the null, you're going to use one of the top 2 boxes on the chart. And if the claim is the H1, you're going to use one of the bottom 2. And so our claim is the H1, and so we would be in one of the bottom 2 boxes. And then we look at whether we're going to reject the null or not reject the null. We said reject the null, which is going to push us into the bottom left box. And if you look in that box, it should say there is enough evidence to support the claim. And so I'm going to write that down. There is enough evidence to support the claim, and then we're going to finish it up. But think about that for just a second. The claim was that the average credit card debt was less than $32.62. We proved that by looking at $29.95 and showing that it was significantly less. So there is enough evidence to support the claim that the average credit card debt is less than $32.62. And so is the Student Senate correct? Yes, the Student Senate felt like the debt was less, and so we proved that yes, our evidence supported that as well.